Imagine launching into space for what's supposed to be a one-week mission. You say goodbye to your family, promise you'll be home soon, and prepare for a short stay aboard the International Space Station. But then, something goes wrong. That's exactly what happened to NASA astronauts Butch Wilmore and Suni Williams. In June, they boarded Boeing's Starliner capsule for a brief test mission. But when the capsule ran into serious technical problems during docking, their return was delayed again and again until they ended up spending nearly 10 months in space. It wasn't the plan, it wasn't expected, and while they never felt stranded, the world watched as they drifted hundreds of miles above Earth, isolated from everything familiar. Eventually, they returned safely in a SpaceX capsule, but their long, unintended stay gave scientists a rare and powerful opportunity to study what happens when the human brain is pushed far outside its natural environment. Because space is not just cold and dark, it changes you. Here on Earth, gravity is a constant force pressing us down. Our brains, organs, and even our thoughts evolved in response to that pressure. Take it away, and strange things begin to happen. In space, your body no longer knows which way is down. Fluids that usually settle in your lower body begin to rise. Blood, water, and cerebrospinal fluid all shift toward your head. Astronauts often describe a feeling of pressure in the skull, like hanging upside down for too long, but without ever flipping upright again. This leads to something astronauts jokingly call the puffy head bird legs effect. Your face swells up, your legs shrink, but deeper inside, your brain is quietly undergoing far more serious changes. With no gravity to anchor it, your brain shifts upward inside your skull. The fluid that cushions and protects it, called cerebrospinal fluid, or CSF, starts pooling differently. The spaces that store this fluid, called ventricles, expand. Imagine the inside of your head starting to feel tight, almost bloated. It's not painful, but it's disorienting. Your sense of balance, governed by your vestibular system, which relies on fluid movement, starts to fail. Some astronauts get space motion sickness, where you feel dizzy, nauseous, and disoriented. It's like being seasick, but with no land in sight and no way to regain your footing. Recent studies show that if you stay in space for 6 months or more, the changes to your brain can last for years. Scientists using MRI scans found that astronauts who spent extended periods aboard the ISS had ventricles that were still enlarged 3 years later. This matters because CSF and ventricular health are linked to diseases like Alzheimer's and other forms of cognitive decline. When this system doesn't flow correctly, your brain has a harder time clearing out waste. Proteins like amyloid beta and tau, which build up in degenerative brain diseases, and the glymphatic system, the brain's garbage disposal, relies heavily on CSF flow and blood circulation. In space, blood flow to the brain decreases while fluid-filled compartments expand, meaning the brain may struggle to remove harmful waste. So while astronauts like Wilmore and Williams didn't report serious cognitive issues after their mission, scientists worry that extended stays in space could silently increase the risk of long-term brain damage. Most of these changes happen gradually, but astronauts describe the experience in vivid terms. Pressure in the skull. A dull, full feeling in your head, like you're constantly congested. Confused balance. Without gravity pulling down, your inner ear can't tell up from down. Moving your head feels weird. It can make you nauseous or dizzy. Blurry vision. Some astronauts experience changes in eyesight. pressure from fluid buildup can flatten the back of the eye. This is part of what's known as spaceflight-associated neuroocular syndrome, SANS, brain fog. While not universal, some report feeling mentally slower or more forgetful, especially early in a mission. And then there's the emotional strain. You're floating in a metal tube 250 miles above Earth. Time slows. You don't feel gravity, weight, or wind. There are no trees, no weather, no real human contact, except for the few other people floating beside you. For Wilmore and Williams, that isolation lasted 286 days. One of the most concerning findings is that the brain may not fully recover. In astronauts who had been to space before, researchers found that if their previous mission was more than 3 years ago, their brains had returned to normal and experienced expansion again. But if they had flown within the last 1 to 3 years, the ventricles did not expand again, implying they never fully shrank back from their last mission. That might mean the brain's ability to adapt to Earth's gravity after spaceflight is limited and could degrade further with repeated missions. But the brain is also incredibly resilient. In those who stayed in space for a full year, the expansion leveled off, suggesting that the brain might adjust and stop worsening after a certain point. For future missions to Mars, which would likely take over a year, this is a small glimmer of hope. You might wonder, if you're not planning a trip to space, why does this matter? The answer lies in what it teaches us about aging and brain health on Earth. The same systems that break down in space, CSF flow, blood perfusion, and waste removal, are involved in dementia, Alzheimer's, and other cognitive diseases. Studying astronauts helps us understand how these systems work and how to protect them. For example, exercise increases blood flow to the brain, which may help drive the glymphatic system and remove waste more effectively. So just as astronauts train hard to prepare their bodies for space, we might benefit from similar practices to protect our brains here on Earth. Suni Williams and Butch Wilmore didn't sign up to become medical case studies, but their unexpected time in space gave science a rare gift, the chance to see how the human brain changes when you take away the very force it was built around. They floated for nearly 10 months in silence, surrounded by stars, their brains slowly reshaping themselves to survive in a place no human was ever meant to be. They returned as pioneers, not just of space exploration, but of human biology. And the truth is, if we ever want to send people to Mars or build a permanent presence in space, we have to understand the dark side of leaving Earth. Because in space, gravity lets go of you, but your brain doesn't let go of Earth quite so easily.